All right, so we are going to be talking about static electricity, and we're going to do a little note on the basics of static electricity. So you can either write this out yourself or you can print out the fill in the blank note that you have available to you in the cloud. So all matter is made up of particles, and all of those particles have positive and negative charges in them. Okay, and what we're going to learn later in the note is that the positives live inside of the nucleus and don't move. And the negative charges, they are outside and they do move. Oopsie. Okay, so all objects have positive and negative charges in them. Neutral objects have an equal number of positive and negative charges. So that means that their total charge equals 0. All right. And when two different neutral substances are rubbed together, one is always going to become positively charged, so it will have more positives than negatives, and one will become negatively charged, it will have more negatives than positives in it. So there's 3 laws to electric charges that we're going to follow. One is that like charges repel one another. You already have experience with this. If you've ever tried to put 2 magnets together off your fridge and they just push apart and you can't get them together, that's like charges repelling. Okay, so the example we're going to use is this object here is going to have +2 in it. Okay, so I'm going to use the purple to denote the positives, and I'm going to make this one +2 as well. It would be very rare that they would both have the exact same number of positive charges in them, but we're just going to do that for this example. And I'm going to do the math off to the side here, so +2 and +2. All right, then in this object over here, I'm going to give it -3. So it has 3 negatives in it. All right. And in this object over here, I'm going to make it -4. So what I want to show you is it doesn't have to have the same number of negatives in it. It just has to have an overall negative charge to repel. So this is +2 take away 3 equals -1. So that gives this object here an overall negative charge. And this one here is +2 -4 equals -2. So that means that this object over here has an overall negative charge, and these two objects are now going to repel each other. What I'm going to do below is show you if they were both positively charged. So this object is going to be +3, and this object here is going to have +4 in it. Okay, so here's my start of the math, +3 +4, and this object is going to have 2 negatives in it. And this object over here is also going to have 2 negatives in it. Again, it will be very rare that they have the exact same number of charges. So I'm going to have +3 -2 and +4 -2. And when I do that math, I have +1 is the charge on this object here, and +2 is the charge on this object here. So overall, these objects have positive charges and they are pushing each other or repelling each other away. Okay, now the next thing that we're going to look at is the fact that unlike charges, or you've probably heard the saying opposites, attract one another. Okay, so we really only need one diagram here to show this. I'm going to put +2 here and +1, 2, 3 here. So +2 +3, and then in this object, I'm going to give it 1, 2, 3 negatives, 3. And this object over here, I'm going to give 2 negatives, -2. So once again, I do the simple math. So I have +2, -3. Okay, and that equals -1. So this object has an overall negative charge. And then over here I have +3, -2 equals +1. So this object over here has an overall positive charge, and they are attracted or drawn together. Okay, now the last law of electric charges, so there are 3 laws altogether, is that neutral objects attract one another. So remember that a neutral object is an object that has 0 charge. Okay, so neutral equals 0 charge. So my first example will be a negative rod. Okay, so this rod will have 1, 2, 3, 4, 5 negative charges in it and 2 positives. Okay, so that would mean that this is +2, -5, which equals -3, giving this rod an overall negative charge. And this object here, I'm going to just move my paper over. I'm going to put 1, 2, 3, okay? And if neutral equals 0, that means it has 1, 2, 3 negatives as well. So -3 +3, okay, and if I do the math down here, +3, -3 equals 0 for neutral. So then this negatively charged object is going to be attracted to this neutral charged object. And perhaps there may be a transfer of charges. We don't know yet, depending on what those objects are. That's what's to come next. So then this object below, again, will have +3. Okay. And this will be -3. Okay. So +3 take away 3 still equals 0 as it did above. And I'm going to give this rod -2. Okay. And +5. Okay, so I have +5, -2. If I do the math over here, +5 take away 2 equals +3, giving this rod an overall positive charge. And this rod will now be attracted to this neutrally charged object. Okay, so this example below, we're going to just briefly skip over it. Or go through it very quickly, but there's generally not 3 and 5 and 4 charges in an object. Objects have millions and millions of positives and negatives in them because they are subatomic particles, and we have to count them up. So in this example, we're just going to quickly count up all the positives and all the negatives. So I have 1, 2, 3, 4, 5, 6 here, so +6, okay? And negatives, I have 1, 2, 3, 4, 5, 6. -6. So this object is neutral, no charge. Over here I have 1, 2, 3, 4, 5, 6, again, +6. And you can see 1, 2, 3, -3. So that means +6 take away 3, okay, gives me an overall charge of +3. So this object is positive, okay? This object over here has 1, 2, 3, +3, and if I count up my negatives, 1, 2, 3, 4, 5, 6, -6, and I do my math, +3 -6 gives me -3. So this object has an overall negative charge. Now, how do objects get charged? That's what we're going to talk about next. And that's the last thing we'll talk about on this little video. So how objects get their charge is through something called charging by friction, which you already have experience with. So we're just going to review quickly the atom, that it has the positives, which are protons, the negatives, which are electrons, and it also has neutrons that we're not going to talk about in electricity, but we do talk about in chemistry, and they are in the nucleus. Okay, so here's the nucleus. Here's my protons or my positives stuck inside the nucleus. Here's my electrons floating or orbiting around outside the electron. They're not, or the nucleus. They're not really floating because they have a lot of energy. So each of these is a -1 that's orbiting around. Okay, so now you rub two objects together like you did with the balloon or the fur and the rod, and you transfer some of these electrons from one object to another. And so there are 4 things we need to talk about with the electron theory of charge. Okay, so when two neutral substances, remember no overall charged, are rubbed together, the electrons are loosely held. So in these outer orbitals up here, they're going to be given away very easily to another object. So as a result, one object gains electrons while another object loses electrons, making one object positively charged and one negatively. Okay, so the object that loses electrons now has a positive charge. Okay, so electrons have left you, something negative has left you, you're going to be happy or you're going to be positive. The object that gains electrons now has a negative charge. Okay, so the overall conclusions that we can come up with from this is that objects with more electrons are negative, and objects with more protons than electrons are positive. Whoopsies, positive. Okay, so now how do we know what's going to become positive and what's going to become negative? That's what you are going to figure out in class next.